Oh, hello, welcome back. Brendan, we are now working on exercise 1.3. So, we have worked out the first main of it. Now, the second main will be concentrating on. So, what does the second main say? Without actually working out, without actually, so it says, you know that 1 by 7 is 0.142857 recurring can be predicted with the decimal expansions of. Now you have to using that as the help, you have to predict what are the decimal expansions of 2 by 7, 3 by 7, 4 by 7. Okay, in the in so let us see what is going to happen. Just look into this. When you are multiplying 1 by 7 is nothing but 10. So you're getting this number, that is 1 by 7 comes to 0.142857. And when you're saying 2 by 7, you're getting 0.28. So you see here, this is 14, this is exactly 2. So 14 into 2 comes to 28. So 2 by 7 is 28. That is 14. When this 0.14 is multiplied by 2, you get 0.28. So in the same way, if I have to have it as 3, I have to have it as 0.14 into 3. It comes to 0.42. Let us check it out. Okay. This is so you have to see that what is this? So 0.14 is what you get by 1 by 7, and 2 by 7 is 0.28. So that is 0.14 is multiplied into 2, you get 0.28. When it is multiplied by 3, 0.42, and so on. Okay, so that is how you without actually calculating, you have just understood that it is like that. Okay, so now let us go to the third main of it. What does the third main say? Represent the following rational in a rational number form, that is p by q, where p and q are integers and q is not equal to 0. You have to represent it in that particular format. So now let us take the first sum. First sum says represent 0.6 bar. When you say what is that bar on the top, the bar on the top indicates that it is a recurring digit. So let us solve that problem. So you have to represent, you are supposed to represent 0.6 bar as a rational number. So I would say let 0.6 bar be equal to x. I am multiplying 10 both the sides by 10. So 10 into 0.6 bar is equal to 10 into x. So this becomes 6.6 bar is equal to 10x. You may ask me why the 6. So this 6 is nothing but it is 6, 6, 6. It continues. So this also 6 continues, right? Because it's having a bar. This is having a bar on it, so 6 continues. So now this can be written as 6 plus 0.6 bar is equal to 10x. I can write it in this format. And I know that this is nothing but x, right? As our assumption, x is equal to this. So 6 plus x is equal to 10x. So 6 is equal to 10x minus x. So 6 is equal to 9x. So x is equal to 6 by 9. So this is nothing but 2 by, in the simplified form, 2 by 3. So this is the representation of 0.6 bar in the form of p by q, and hence you can say that 0.6 bar is a rational number, Just have a look at this. Okay, so in this way you can prove that a given number can be represented, if it is a rational number, it can be represented in the form of p by q. where q is not equal to 0, be it a recurring digit, same digit is recurring, or a group of digits is recurring. It is not that it is, so obviously it is non-terminating, but it is recurring. Fine. So now let us see how to the next sum. The next sum is represent 0.47 bar. In this case, what is it? Only this 7 is recurring. Our first 4 came, and after that everything is 7, 7, 7, 7. So let us say, let, okay, 0.47 bar be equal to x. Whatever number is given, you take it as equal to x. Now, since this is only one which is recurring, so we will multiply both the sides by 10. 10 into 0.47 bar is equal to 10x, right? So this becomes, how much when 4 comes aside, it becomes 4.7 bar is equal to 10x, right? Now this 4.7 bar, how can I write it in the, I want to get it in this format. So what will I do? This 7, I'll have to, what will I have to do? Tell me what I'll have to do. This sum is a little bit tricky here. Now you got 4.77 is this 7 is repeating, so I will written this 7 is equal to 10x. Now what I will do is I will subtract x from both the sides. So 4.777 bar minus x is equal to 10x minus x. Okay, so this x is nothing but 4.7 bar minus 0.47 bar is equal to how much? 9x. Okay, so if I do this, what will happen? What will I get? I will get 4.3, because the first one, only the first 7, from the first 7 this 4 get cancelled, I mean subtracted, so you are left with 3, rest everything gets cancelled because 7 7 and 0 is equal to 9x. So 4.3 is equal to 9x. So x is equal to 4.3 divided by 9, that is equal to 43 by 90. This is a representation of 9.47 bar in the rational form P by Q. This sum was a little bit tricky to understand. When we solve some more sums, you will be able to understand the same line. We will try some more sums later, so you will be able to understand how to do it. Okay. So at the end of the day, you want to get that 0.47 bar. So in order to get that, what you have to do, that is what it was done. Okay. Now your next sum is represent 0.001 bar in P by Q format. So say let x be equal to 0.001 bar. So this is equal to 0.001001. Okay, just bar. It means the same number is continuing. So now this is equal to x. I am multiplying, this is 1, 2, 3. So I'll multiply it by 100 on both the sides. Into 100 is equal to 100 into 0.001001 bar. So this is 100x is equal to 1.001 bar. So this 100x is equal, I'll be writing this as 1 plus 0.001 bar. So this again will be 100x is equal to 1 plus, this is nothing but our x. So x, so 100x, this minus x is equal to 1. So 99x is equal to 1. So x is equal to 1 by 99. So this is the representation of 0.001 bar in the rational form P by Q, where P1 and 99 are integers and Q is 99 not equal to 0. I hope you're able to understand these things. So let us now proceed a little bit further. Just hold on. Let us see the next sum now. Now let us solve question number 7. What does the question number 7 say? Question number 7 says, write three numbers whose decimal expansions are non-terminating and non-recurring. Non-terminating and non-recurring, it clearly says that they are irrational numbers, right? Because our rational numbers are terminating and recurring, non-terminating and recurring, or terminating. So these are the two conditions for rational numbers. But here they have asked you, give decimal expansions for three decimal expansions for non-terminating and non-recurring decimals. So which are the non-terminating? So you can surely say, what is that? Root 2, root 3, root 4, not root 4, root 5. So you have these three irrational numbers. You can surely use these numbers to represent them. Or else you can take any two rational numbers and which are in the form P by Q, I mean to say, and then you find out irrational numbers in between them. Let us see how we do that. So I take two rational numbers, 3 by 5 and 4 by 7. So let me find out the decimal representation of 3 by 5. So this is 3 and this is 5. Okay, zeros are 0.6, 5, 6 are 30. Fine, it becomes 0. So it is 6 terminating. Then I have 4 by 7, 7, 0. What comes? 7, 5 are 35. 7 5s are 35. Okay, and remainder is 5. I add a 0. 7